Hi everyone, can you hear me? Can you hear me?
Yes, doctor.
Okay, all right, good. Okay, so can you see the screen as well?
Yes.
Okay, good. Okay, just before we start, I would like to have the four of you, No Ainun Anis, No Anis Adila, No Ani Suhaini, and Sun Yok Khan. These four of you, please stay back after the post-mortem, okay? So I would like to have more interactions with you guys, so please talk, okay? So, okay, let's get started here. Okay, so the first questions here we're going to start with today is asking you whether do you need to do a tonicity adjustment or not for this following preparations. Okay, so so the tricky parts here for the questions is because of the different units given, okay, for your calculations, especially for your freezing point depression value and the related units. Okay, so one of them appears from Sprout's method where the v is equal to 0.3. Okay, so in this kind of situations, which I think you won't face anymore in the future because this will usually appear in, for example, like your multiple choice questions that I don't limit you the choice of methods. So if I don't limit you the methods that you need to do, so you probably can go to the easiest one. So yeah, so and then another thing is here we have a different units. Okay, so can any one of you propose how you think you want to solve the problems? Any one of you just tell us how you think you want to solve it. Okay, so I wanted to know more about how you think about these questions. Anyone? Are you guys here?
Hello, doctor.
Yes. Can you?
Can I use the sodium chloride equivalent method?
Yes. And then how do you think you want to solve the questions?
Okay. For the first one, I use the V 0.3 gram of anti-COVID drug. So I use the Vincent White method. I got the E1% of anti-COVID drug.
Okay. You get this one change into E1%.
Yeah. So and then I calculate the E1% of sodium metabisulfite.
Okay.
And I calculate the E1% of benzalkonium chloride. And then I use the sodium chloride equivalent method. And then I calculate I got 0.5% of sodium chloride equivalent method. So the tonicity adjustment is needed in the formulation.
Okay. All right. Thank you. So very good and clear explanations. I think you can actually use anyways, but apparently over here using sodium chloride equivalent method is not I won't say it's not the best way, okay, but it's gonna be a bit tedious, okay, because you need to start converting this into another unit. Okay, over here I think the two clear pass again I say is because of different units. Okay? And if I don't limit the most easiest one, which is your freezing point depression method. Okay, so since the most of them appear in delta TF 1%, so might as well you just change this one, the V 0.3. Okay, you convert using the Sprouse method, convert to E1%, and then you convert into delta T 1%. Okay, once you get the delta T 1%, then what you have to do here is to convert here again into standard unit for the freezing point depression method, okay, which is in percentage. So the two ingredients here are already in percentage. And again, I say, for things like benzalkonium chloride, you know, it's a preservative and in small amount. So probably you can also ignore, okay? Even though it's given here, when you try to calculate, because you can see the freezing point depression value for benzalkonium chloride itself is also very low. So in this case, for the concentration also very low. So when you try to multiply, then you get a very, very insignificant value, okay? Okay, so what you need to do here is to convert this one into percentage. Okay. Okay, then you use your value b equal to 0.52 minus a divided by w. Okay, divided by b. Okay, so what you have to do is to have all the percentage times the freezing point depression value to be substituted into a, and then your b will be the selected one. Okay, so you can just choose either of them to be put here. So then you calculate whether the amount here equivalents to the amount given. Okay, if it's not equivalent, then you know that this is not isotonic. Okay, so is that clear? Can I get some response? Do you have any questions?
Yes, clear, Doctor.
Okay. Okay, so this is one of the way. So you can also use the other ways like let me check. Get clear first. Okay, so and of course you can also use other methods. Okay, so you can use sodium chloride method as your friend says. So but the main thing here you need to be clear is what is the units given. Okay, what is the unit given? Okay, what is the value given? Okay, so once you're clear with this one, then you don't have the problems. And also I noticed a lot from what you did in the tests and also in the exercises is that you guys always forgot that the value given here, whether it's delta TF, E1%, okay, or V or V.3, okay. So all these values are referring to a certain amount of the ingredients. Okay, so when you're given here is not according to the amount here, which delta TF is 1%, E is for 1%, and V for one reason it depends on the amount, but the V 0.3 grams is referring to 0.3 grams. So you need to know to convert. Don't forget to convert this value into the percentage or the amount or the concentration given in your questions. Okay, so this I always found this is the major mistake. Okay, when you get the delta TF or you get the E1% or you get the V, you will start to add up everything together without considering actually this is referring to a certain amount but not the same amount as in your questions. Okay, so okay, so if you wish to use V is also okay, or if you want to use V 0.3 since Sparks method is given, so you can also change this one all to V 0.3. Okay. So what you have to do is to convert all these ones into the amount, okay, into gram. Then you do a relations to see whether you get the final amount same as here. Okay, then you will know that in the given volume here. So then you know that whether this formulation is isotonic or not. Okay, so it depends on the methods. Okay, so in this case here, okay, so you don't need to follow exactly 25 mil. Okay, the 25 mil here is just a value to confuse you. Okay, so you need to know whether the value here, each of the values mentioned here is important or not for you to calculate. Okay, so in this case, because all the unit given here are in concentrations, okay, so which is an amount of drugs, okay, amount of drugs in a certain volume. Okay, so which means that this value actually is not needed, okay, for you to calculate. Okay, if you know If you know this trick, then you know. You don't have to get confused by 25. Even you can do V 0.3 gram for 100 mil, okay, because you can always convert all this into 100 mil, okay, unless here I'm giving you 5 milligram. Okay, if I give you 5 milligram, then the 25 mil is important because you need to know that in these formulations, there is 5 milligram of this drug in 25 mil of the overall formulations. Okay, right? So if that is okay, then I will go to the next questions. Any more things you want to add about these questions? Okay, some of your friends already posted solutions in the e-learn, so I think you can also refer them. Okay. All right, so then I will go to the next one. Okay, so over here, with a very similar questions. Okay, so the major difference here for the first question and second questions. Okay, the first one. Okay, over here I said tonicity is not needed for the following formulation. I didn't specify this as an eye drop. Okay, so if I specify this as an eye drop, probably the answer will be different. Okay, but over here for questions 2, I asked specifically for eye drops. Okay, so then the rules apply again. Okay, you remember the acceptance based on the sodium equivalent method. Okay, so and if it's not okay, and over here I give you the hints that it is an isotonic. So when it's isotonic, you know that it must be equivalent to 0.9% of sodium chloride. Okay, so this is the basic rules you should always need to know. Okay, so and again here I tell you this formulation is isotonic. I want you to find the E1% of the drug AVA. So can someone propose how you want to solve the problems? Anyone? If you're given this, how you think you want to solve the questions? And what kind of method you think you want to use? Please, someone share your opinions.
Hello, doctor. I use the
Yes.
NaCl equivalent method.
Yep.
So I will convert the drug TER to, I will find the E1% for sodium thiosulfate and the drug TAR.
Okay, you convert all to E1%.
Yes, and then I will find the percentage of NaCl equivalent based on percentage that is in the formulation. I will compare.
Okay, you convert them based on the percentage.
And
Okay.
then for isotonic solution, we know that it is 0.9% NaCl. So
Yep.
I will minus with all the percentage NaCl equivalent in the formulation.
Yes.
And then I will get the percentage of NaCl equivalent for the drug AVA.
Yep.
And then for the E1%, which is 1% of drug AVA, I will compare because the percentage that I get is just for the percentage of AVA in the formulation. But for 1%, I have to like do ratio to get the percent punya value.
Yep. Thank you. Okay. Very good. Again, I think it's very clear. So just let me wait. Just let me get okay. All right. Okay. So again here, it doesn't matter which method you use. Okay. So the most important thing you want to achieve is to find out the isotonicity of this reagent. Okay. So because it's given isotonic, so meaning all of these ones added up should be isotonic. So no matter which method you use, let's say if you want to use the more basic ones, okay, again, freezing point depression value. So you just have to convert this V 0.3 to E and then to delta TF. Okay, so then you can use again your equations. Okay, so you can use the equation here. Okay, sorry, I have some disturbance here. Okay, sorry again. So you convert this one into E and then delta TF. So then you convert all this one into percentage. Okay, so only these two you need to convert, and I don't give you the delta TF for the precipitate. So basically, you can ignore this one. Okay, so but over here, okay, the value for the final amount is important. Okay, for the final amount is important because the AVA drug is given in amount. Okay, so you have to convert this one into percentage and this one as well. So 3 dot 250, which means 3 gram in 250 ml. So you just have to convert that. So again, back to your equations. Okay, so over here, instead of finding W, okay, your mission here is to find out the B, which is usually the delta T F for the additional substance. Okay, so over here, because all substances are given, so you just have to assume in this case that your AVA drug is the unknown. Okay, so but you know the amount in terms of percentage. Okay, so this is another mistake always people make. Okay, the W here doesn't refer to gram. Okay, it's referring to percentage. Okay, and minus the A here, which is all these three items. Okay, all these three items multiplied with the delta TF value. Okay, to be added over here. Then you finally will get your B value. Okay, your B value again is delta TF. What you have to do is to convert the delta TF into E 1% by dividing with your delta T of your sodium chloride. Okay, so is that clear? Okay.
Yes, doctor.
All right. Thank you. So this is again we discussed about sodium chloride equivalent methods. We discussed about the freezing point dimensions value method, and of course you can then again use the V 0.3, okay, which is a Sparks method, or if you want to complicate yourself, okay, so you can use a White Vincent. Okay, so let's say you use Spark or White Vincent, doesn't matter. If you just do the V 0.3, you just have to convert all this into V 0.3. Okay, so and over here the final amount then become important. Okay, this value become very important because your total amount to be isotonic is 65. So everything's over here. Again, you have to convert them into gram. Okay, based on the amount, the volume here, and then you just have to use the V 0.3 to be changed into the amount available in this given volume. Okay, so in 65 ml, and for each of the gram, how much it contribute, then again you can then calculate for this AVA. Okay, you will get the V 0.3 for AVA, then you just have to convert that into E1%. Okay, so again, the situations will always be just turning around like this. Okay, whether I give you the full list of ingredients with the amount, with the delta TF value, or it can be just the other way around. Okay, so you just have to be clear that how you're going to use your equations. Okay, and understand how the equations is being derived from. Then you won't get wrong. Okay. So if nothing, I will. Okay. Any questions you want to ask for these questions? Okay. If no, then I will proceed to the last one. Okay. So the last one I think is even more easy. Okay, so apart from the molecular weight, which I forgot to give you. So, but anyway, the questions here will not be difficult. Okay, the main things I will be challenging you is your unit. Okay, you have to be clear with unit always. Okay, simple conversion like this you should master. Okay, and again, you remember I give you the conversion of the unit from gram per liter, or from the percentage to gram per liter, then to millimole per liter to milliequivalent per liter. Okay, so remember you times a certain factor or divide by a certain factor. So again, this is to how to say, to make your life easier, but I think you need to know the reason behind, or how you can convert the percentage to gram per liter, because you may not be always given in this value. So if it's not given in this value, how are you going to convert them into each other? Okay, so you need to understand the principle behind for this conversion. Okay. 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 Okay, again, apart from the unit itself, okay, so you shouldn't have any problems here, because again here the volume is important, because there's one ingredient is given in amount. Okay, so you need to convert them into gram per liter or milligram per liter. This is where your starting point before start to converting into millimole or milli equivalents per liter. Okay, you need to know how to convert the unit here into this standard unit. Okay, else you will have difficulty again to change. Okay, because the following things will be very, very simple. You just have to get to know the molecular weight and the valency. Okay, so another things I want to ask you guys is the valency. Okay, so as I say that you won't be given the valency, or you won't be given the chemical equations or formula. Okay, so you need to know by heart that if sodium acid phosphate. Okay, so for there's how many valency for sodium? Valency for sodium 1 plus acid phosphate
-1.
1 minus. Okay, so sodium again 1 plus sodium phosphate, phosphate ion, with a valency of phosphate.
-2.
Yeah. Okay, so magnesium
2 plus.
2 plus. Thank you. Then sulfate
2 minus.
2 minus. Thank you. All right, so once you get clear with this one, then we now go to the mole. Okay, so sodium and acid is the mole. How many mole of sodium inside the sodium acid phosphate? Go back to your chemical equations. So how many mole of sodium? 1. Acid phosphate?
1.
Yep. Thank you. Sodium phosphate, sodium? How many
2.
mole of sodium? 2. Phosphate?
1.
Yep. Correct. So magnesium sulfate, magnesium?
1.
Yep. Sulfate?
1.
Yeah, all right. Okay, so this should be the basic information you know by heart. Okay, so once you are clear with this one, so whatever number is given here to you, okay, it doesn't matter. Okay, so what you have to do is just to have to multiply or divide by this number. Okay, so for millimole, you have to know that you have to multiply or divide by this mole. Okay, but for milliequivalents, then you have to consider the valency. So this is the most easiest way that you can think of to solve the problems. And again, the sort given will be just more or less like what you have in the list. Okay, available in your lab manual. Okay, or in the BBC also, there is one list in the appendix. Okay, so the more extent that I can challenge you would be the units. Okay, so you must be clear with the units. Okay, if you're not clear or you don't understand how the units can be converted or what the unit means, then you will have a problems. Okay, so you just need to narrow down to know this one. Then whatever value given doesn't matter. Just have to multiply with 1, 2, 1, 2, or 1, 3, or 2, 3. Okay. So and again, I want to remind you again. So millimole, you may not get both cation and anion the same. Okay, but milliequivalents, okay, in a given amount, usually in a liter, okay, must be the same for both cation and anion. Okay, so if you don't get this, meaning that there is something wrong with the calculation somewhere. Okay. So, and again, another trick that you can think of if you want to check your, okay, again, again that you have this value. Okay, you can construct your table. Okay, you can construct your table with this simple value to 1, So what you have to do is just multiply this 1, 1 and 2, 2 again with the calculated value. Okay, so this will be another way for you to avoid confusions. Okay. So any questions for this one? So any questions? Okay. If no question, then I will have to stop this thing. Or if you have any other things you want to ask, anyone?
Doctor, I want to ask, the question didn't ask for is it the formation is isotonic, but should I just write it? I mean, the question asked for calculate the MEQ for all the ions.
Yeah.
So we just state is it isotonic or not?
No, there's no need.
No need.
Okay. So you have to see the question here, because this question I didn't ask you, and of course I didn't ask. Okay, I didn't ask you. You don't need to, because over here I didn't even specify this is an isotonic infusion. Okay, if I specify this is an isotonic infusion, then probably in the questions design I will probably ask you to add in something to make it isotonic. Okay, or you need to know that you need to add something to make it isotonic if the calculation end up is not isotonic. Okay.
Okay, doctor.
So any more questions? Okay. If no, then I will end the sections today, but I will